While NASA and SpaceX dominate today's headlines about Mars exploration, the most daring attempts to reach the Red Planet happened 60 years ago behind the Iron Curtain. The Soviet Union launched secret Mars missions that were so advanced, so ambitious, and so catastrophically dangerous that, honestly, they make Elon Musk's Starship look like a neighborhood science project. These missions literally exploded on launch pads, crashed into alien soil, and vanished into cosmic silence, but they paved the way for everything we know about interplanetary travel today. Did you know the Soviets actually landed on Mars before anyone else, but it was completely by accident? The beginning. While everyone was obsessed with the moon landing in 1969, the Soviet Union was quietly plotting something far more audacious, a mission to Mars that would make Apollo 11 look like a neighborhood joyride. The space race wasn't just about planting flags on lunar soil, it was about who could conquer the ultimate prize, the Red Planet. Behind the Iron Curtain, Soviet engineers were designing spacecraft that could travel 140 million miles through the cosmic void, endure radiation storms, and attempt humanity's first landing on another world. This wasn't science fiction, this was Cold War reality. While Neil Armstrong was taking his famous first steps, Soviet mission planners were already calculating launch windows to Mars, designing heat shields that could survive atmospheric entry at 12,000 miles per hour, and developing communication systems that could beam signals across interplanetary distances. The Soviet space program had already shocked the world with Sputnik in 1957, and Yuri Gagarin's historic flight in 1961, but their Mars ambitions were on an entirely different scale. These weren't just orbital missions or lunar flybys, they were attempting to land functional spacecraft on a planet where temperatures swing from 70 degrees Fahrenheit to minus 195 degrees Fahrenheit, where dust storms can rage for months, and where one miscalculation means losing everything in the dark expanse of space. What happened next would change everything we thought we knew about the space race, and most of the world never even heard about it. Mars 1. A single radio signal from 140 million miles away changed everything, and then went silent forever. On November 1, 1962, the Soviet Union launched Mars 1, an 894-kilogram metallic behemoth packed with cameras, spectrometers, and enough scientific instruments to revolutionize our understanding of the Red Planet. This wasn't just another satellite circling Earth. This was humanity's first serious attempt to reach another world, and the Soviets were betting everything on it. The spacecraft was a marvel of 1960s engineering, solar panels that could function in the weak sunlight beyond Earth's orbit, a communication system designed to transmit data across interplanetary distances, and a heat shield capable of surviving the brutal journey through space. For 106 days, Mars 1 hurtled through the cosmic void, its trajectory perfectly calculated to intercept Mars during its 1963 closest approach to Earth. Soviet engineers monitored every signal, every telemetry reading, as their creation became the first human-made object to venture into deep space with a specific destination in mind. The mission was so classified that even NASA didn't fully understand what the Soviets had achieved until years later. But on March 21, 1963, at a distance of 65.9 million miles from Earth, Mars 1 transmitted its final signal, a weak radio pulse that faded into the cosmic silence. Radio Moscow never officially announced the mission's failure, but behind closed doors, Soviet scientists knew they had lost their first ambassador to Mars somewhere in the vast darkness between worlds, carrying with it humanity's first real dreams of interplanetary exploration. Mars 2. Two identical spacecraft sat on launch pads 3,000 miles apart, each carrying humanity's most sophisticated interplanetary technology, and both were about to become monuments to cosmic ambition and earthly miscalculation. The Soviet Union's Mars 1969A and Mars 1969B missions represented the pinnacle of Cold War space engineering, featuring advanced panoramic cameras, soil analysis equipment, and atmospheric sensors that could have rewritten textbooks about planetary science. These weren't simple flyby missions like their predecessor. These bus-sized spacecraft were designed to actually land on Mars and transmit the first close-up images of the Martian surface back to Earth. Soviet engineers had spent 3 years perfecting every component, from the retro rockets that would slow the descent to the shock-absorbing legs, designed to cushion impact on alien soil. The timing was critical. Mars and Earth align favorably for interplanetary travel only once every 26 months, and the Soviets knew NASA was preparing their own Mars missions for the same launch window. On March 27, 1969, technicians began the final countdown for Mars 1969A at Baikonur Cosmodrome. The four-stage Proton K rocket stood 190 feet tall, its liquid oxygen and kerosene fuel tanks pressurized and ready. At exactly 10:40 Moscow time, the engines ignited with a roar that could be heard 20 miles away. For 51 seconds, everything went perfectly. The rocket climbed steadily through Kazakhstan's morning sky. Then, in an instant that would haunt Soviet space officials for decades, the entire assembly disintegrated in a fireball so massive it registered on seismographs across Central Asia. Mars 1969. The shockwave shattered windows 15 miles away, and in that single catastrophic moment, the Soviet Union lost not just a spacecraft, but their best chance at beating America to Mars. What should have been the triumphant launch of Mars, 1969A instead became one of the most spectacular and most covered-up disasters in space exploration history. The Proton K rocket had barely cleared the launch tower when its third stage suffered a catastrophic engine failure, turning 500 tons of rocket fuel into an airborne inferno that painted the Kazakh sky orange for 37 seconds. Soviet officials immediately declared a media blackout. No photographs, no news reports, no acknowledgement that anything had even happened. But you can't hide an explosion visible from orbit. American spy satellites captured the entire sequence, watching as debris rained down across a 50-square-mile area of the Baikonur Cosmodrome. The blast crater measured 200 feet across and 30 feet deep, and radioactive fuel contaminated the launch pad for months. More devastating than the physical destruction was what burned up in that fireball. 7 years of Soviet Mars program development, millions of rubles in cutting-edge technology, and the careers of dozens of rocket engineers who were quietly reassigned to other projects. The backup mission, Mars 1969B, was indefinitely postponed as investigators sifted through the wreckage, trying to understand how their most reliable rocket had become a 3,000-degree funeral pyre for humanity's Martian dreams. Leonid Brezhnev himself reportedly watched footage of the disaster and declared that Mars missions were too dangerous to continue. Mars 1971. Against all odds and political pressure, Soviet engineers refused to surrender their Martian dreams. And on May 19, 1971, they launched what would become both their greatest triumph and most heartbreaking near miss in space exploration history. Mars 2 lifted off from Baikonur with the weight of the entire Soviet space program on its shoulders, carrying not just scientific instruments, but the redemption of a nation's cosmic ambitions. This time, everything went flawlessly. The Proton K rocket performed perfectly. The trajectory calculations were precise to within 0.001 degrees, and for 193 days, the spacecraft hurtled through space toward its December rendezvous with the Red Planet. Soviet Mission Control tracked every signal as Mars 2 became the first human-made object to successfully reach Martian orbit and deploy a functional lander. The 1,210-kilogram descent module separated perfectly, its heat shield glowing white-hot as it slammed into the Martian atmosphere at 13,000 miles per hour. But Mars itself had other plans. A planet-wide dust storm, the largest ever recorded, had been raging for months, turning the entire Martian surface into an impenetrable orange hurricane. The lander's parachute system couldn't compensate for the chaotic atmospheric conditions, and instead of the gentle touchdown Soviet scientists had dreamed of, Mars 2 crashed into the Christ-Planitia region at terminal velocity. In that devastating impact, the Soviet Union achieved a bitter milestone. They had successfully delivered the first human artifact to Mars, but it was now scattered across several square miles of alien terrain, silent forever. Mars earthquakes. The Red Planet is literally shaking itself apart, and the seismic data is so terrifying that NASA scientists are rewriting everything they thought they knew about planetary geology. On May 4, 2022, NASA's InSight lander detected something unprecedented, a magnitude 5.0 Marsquake that lasted over 6 hours and released energy equivalent to 32 billion joules, enough power to supply a small city for an entire day. This wasn't just another minor tremor, it was the most powerful seismic event ever recorded on another planet, and it revealed that Mars is far more geologically active than anyone imagined. InSight's ultra-sensitive seismometer had been listening to the planet's heartbeat for 1,318 Martian days, recording over 1,300 smaller Marsquakes, but this monster event shattered all previous records. The quake originated deep within Mars's interior, possibly from the Cerberus Fossae region, a network of massive fractures that stretch for thousands of miles across the planet's surface. What's truly mind-blowing is that Mars lacks the tectonic plates that cause earthquakes on Earth, meaning these violent tremors are generated by something else entirely. The planet's core is cooling and contracting, causing the entire Martian crust to crack like a drying mud puddle. French seismologist Philippe Lognon described the data as absolutely extraordinary, revealing that Mars experiences daily seismic activity that would terrify geologists if it happened on Earth. These discoveries completely overturn the old assumption that Mars is a geologically dead world, proving instead that it's a dynamic, evolving planet where the ground literally moves beneath your feet. Mars subsurface lakes. Buried beneath a mile of frozen Martian ice lies something that could, well, totally rewrite the search for extraterrestrial life. Liquid water lakes so vast they actually dwarf the Great Lakes, and they've been hiding there for millions of years. In 2018, Italian planetary scientist Roberto Orosai made a discovery that honestly sent shockwaves through the scientific community. Using radar data from the European Space Agency's Mars Express orbiter, his team detected a 12-mile-wide underground lake beneath Mars's south polar ice cap. This wasn't just frozen water or trace moisture. This was actual liquid water, maintained in its fluid state by a combination of geothermal heat from the planet's core and high salt concentrations that act like cosmic antifreeze. The radar penetration revealed what looks like a subglacial lake system, similar to those found beneath Antarctica's ice sheets, where Earth's most extreme organisms thrive in complete darkness. But here's where it gets truly extraordinary. Follow-up studies using Marcius radar discovered not just one lake, but an entire network of interconnected water bodies spanning hundreds of square miles beneath the Martian polar regions. Orosai's team published their findings in Science magazine, describing radar signatures so clear they're unmistakable. The bright reflections can only come from liquid water interfaces. These subsurface oceans have remained liquid for potentially billions of years, protected from Mars's hostile surface by thick ice and sustained by planetary heat. If life ever existed on Mars, these hidden lakes represent its last refuge, dark, salty sanctuaries where Martian microorganisms might still be thriving right now, completely unaware that curious humans are 140 million miles away, planning missions to drill down and say hello. Mars organic matter. The Martian soil is literally crawling with the building blocks of life, and the evidence is so overwhelming that NASA scientists are frantically recalibrating their entire approach to the search for extraterrestrial organisms. On September 15, 2022, NASA's Perseverance rover made a discovery that sent ripples through the astrobiology community. Organic compounds embedded within Martian rock samples from the Jezero crater, a 28-mile-wide ancient lake bed that once held liquid water for millions of years. These aren't just trace amounts of carbon. We're talking about complex organic molecules including aromatic compounds and aliphatic chains that form the fundamental chemistry of life as we know it. Perseverance's Pixel instrument detected these compounds using X-ray imaging and spectroscopy, revealing organic concentrations 10 times higher than anything previously found on Mars. NASA astrobiologist Amy Williams described the findings as unprecedented, noting that the organic matter is preserved within sedimentary rocks that formed when Jezero crater was a thriving ancient lake ecosystem. What makes this discovery truly extraordinary is the variety and complexity of the organic compounds. They're not random carbon molecules but structured chemicals that could only form under specific environmental conditions. The rover's samples contain nitrogen-bearing organics, sulfur compounds, and hydrocarbon chains that mirror the chemical signatures found in Earth's oldest fossils. Thomas Zurbuchen, NASA's former associate administrator, called it the strongest evidence yet that Mars once supported conditions favorable to life. These organic treasures are now sealed in titanium tubes, waiting for the Mars sample return mission to bring them home for detailed laboratory analysis that could finally answer humanity's ultimate question. Moxie. Deep in the Martian wilderness, a toaster-sized machine is quietly performing alchemy, converting the alien atmosphere into breathable oxygen and proving that humans might actually survive on the red planet without suffocating in 96% carbon dioxide. NASA's MOXIE experiment, or Mars Oxygen In Situ Resource Utilization Experiment, aboard the Perseverance rover, has been working Martian magic since April 20, 2021, splitting CO2 molecules apart and creating pure oxygen at a rate of 5.4 grams per hour, enough to keep an astronaut alive for 10 minutes of normal breathing. This isn't just a cool science demonstration, it's humanity's first successful attempt at living off the land on another planet. The Golden Box uses a process called solid oxide electrolysis, heating Martian air to 1,470 degrees Fahrenheit, and using electrical current to separate oxygen atoms from carbon dioxide molecules. Over 16 successful runs, MOXIE has produced a total of 122 grams of oxygen, more than 4 hours worth of breathable air for a single astronaut. MIT's Michael Hecht, the experiment's principal investigator, described the results as absolutely remarkable, noting that the device has consistently produced high-purity oxygen despite Mars's wildly fluctuating atmospheric conditions and temperature swings of over 170 degrees Fahrenheit. The implications are staggering. A scaled-up version of MOXIE could produce enough oxygen to fuel rocket engines for the return trip to Earth, eliminating the need to transport massive fuel tanks across 140 million miles of space. Mars is literally providing the life support systems that future human colonists will need to survive. NASA SpaceX. The ghosts of Soviet failure are now guiding humanity's greatest space partnership toward Mars, as NASA and SpaceX prepare to land the first humans on the Red Planet, using hard-won lessons written in the wreckage of decades of cosmic disasters. Elon Musk's Starship program isn't just ambitious engineering, it's the direct descendant of every Soviet Mars mission that exploded, crashed, or vanished into the cosmic void. The failures of Mars, 1969A, the heartbreak of Mars 2, and the seismic discoveries of InSight have created a roadmap of exactly what not to do when attempting interplanetary colonization. NASA's Artemis program and SpaceX's Mars architecture incorporate Soviet-era lessons about atmospheric entry, landing systems, and long-duration spaceflight that cost the USSR billions of rubles and countless careers to learn. The partnership officially began with commercial crew missions to the International Space Station, but the real target has always been Mars. NASA Administrator Bill Nelson and Elon Musk have committed to landing astronauts on Mars by the 2030s, using Starship's 100-ton payload capacity to transport everything from habitat modules to MOXIE-derived oxygen production systems. The Raptor engines that will power Starship to Mars burn methane and oxygen, the exact same fuel combination that can be manufactured on the Martian surface using atmospheric processing technology pioneered by failed Soviet experiments. What began as Cold War competition between superpowers has evolved into humanity's unified effort to become a multi-planetary species, built on the foundation of Soviet sacrifices that almost nobody remembers. That's the untold story of humanity's first Mars missions, Soviet secrets that almost changed history. From catastrophic explosions to accidental landings, these declassified missions proved that our journey to the Red Planet started decades before anyone realized. The courage of Soviet engineers and the lessons from their failures are literally powering today's Mars exploration. If this hidden space history blew your mind, smash that subscribe button and hit the bell icon so you never miss our cosmic secrets. Comment below. Which Soviet space mission shocked you the most? More space facts coming your way, space explorers. On September 26, 2022, NASA's DART mission slammed into asteroid Dimorphos, shortening its orbit by 32 minutes, a jaw-dropping 26 times the shift scientists predicted. We didn't merely tap a space rock, we rewrote the playbook on planetary defense in a single, spectacular collision. Earth just proved it can shove mountains in the vacuum of space. Will we do it again when everything's on the line? Did you know one well-aimed kinetic strike could steer a city-killer asteroid clear of our planet? The DART mission. Space debris just became humanity's new superpower. What started as NASA's most ambitious planetary defense experiment turned into the discovery that could save our planet from extinction. On September 26, 2022, the DART spacecraft slammed into asteroid Dimorphos at breakneck speed, traveling 370 million kilometers from Earth to execute what many called humanity's first real-life superhero moment. But here's where everything went beautifully wrong. Instead of the predicted tiny 73-second orbital shift, something absolutely mind-blowing happened that left scientists speechless and completely rewrote the rules of planetary defense. The double asteroid redirection test wasn't just about proving we could hit a cosmic rock the size of a football stadium. This was our species taking its first serious swing at playing cosmic billiards, testing whether we could actually nudge a potentially dangerous asteroid off course before it ruins everyone's day. Launched back in November 2021, DART had one job: crash into Dimorphos, the smaller moon orbiting the larger asteroid Didymos, and see what happens when human engineering meets ancient space rock. Scientists expected a gentle nudge, a small proof of concept that might buy us some confidence for future planetary threats. What they got instead was a masterclass in cosmic physics that exceeded their wildest calculations and fundamentally changed how we think about defending Earth from asteroid impacts. Impact results analysis. The cosmic equivalent of hitting a home run when you were just trying to bunt. When the dust literally settled after DART's kamikaze mission, astronomers pointing their telescopes at Dimorphos couldn't believe what they were seeing. The Hubble Space Telescope and ground-based observatories worldwide detected something that made every planetary scientist do a double-take. This wasn't the gentle tap they had modeled in their computers. The asteroid's orbital period had shifted by an astronomical 32 minutes, not the modest 73 seconds they had predicted. That's like expecting to move a boulder an inch and accidentally launching it across the parking lot. But here's where the real detective work began. The impact results analysis revealed that Dimorphos had essentially turned into a temporary comet, spewing out a massive debris plume that acted like a natural rocket engine. This wasn't just impact physics. This was discovering that asteroids could become their own propulsion systems when hit just right. The momentum transfer was 26 times greater than expected, meaning NASA had accidentally stumbled upon a planetary defense cheat code. Scientists frantically recalculated everything they thought they knew about asteroid deflection, realizing that a relatively small spacecraft could potentially redirect city-destroying space rocks with far less effort than anyone had dared hope. The implications were staggering. Humanity's cosmic insurance policy had just gotten a massive upgrade, and all it took was one perfectly executed space crash. Momentum enhancement discovery. Sometimes the most incredible discoveries happen when your experiment works too well. The momentum enhancement discovery from DART's impact wasn't just a pleasant surprise, it was a complete game-changer that sent shockwaves through the planetary defense community. When scientists analyzed why Dimorphos got knocked around like a cosmic pinball instead of just gently nudged, they uncovered physics that Hollywood couldn't have written better. The secret ingredient? That spectacular debris cloud wasn't just pretty space fireworks, it was functioning as an improvised rocket engine, blasting material away from the asteroid and creating additional thrust that multiplied the deflection effect beyond anyone's wildest dreams. This momentum enhancement effect revealed something extraordinary about how kinetic impactors actually work in the real universe versus computer simulations. The ejected debris acted like exhaust from a rocket, pushing Dimorphos in the opposite direction with tremendous additional force. It's like throwing a baseball and having it somehow gain speed mid-flight. Completely counterintuitive but absolutely real. The 26-fold multiplication of expected results meant that future planetary defense missions could potentially redirect dangerous asteroids using much smaller spacecraft than previously thought necessary. Scientists realized they had witnessed something that could revolutionize how humanity approaches asteroid threats. Instead of needing massive, expensive missions to deflect city-killer asteroids, relatively modest spacecraft could potentially do the job thanks to this newly discovered physics phenomenon. The universe had just handed humanity a cosmic cheat code for planetary defense, wrapped up in the most successful space crash in history. Asteroid structure insights. Some asteroids are basically cosmic sandcastles waiting to fall apart. The asteroid structure insights from DART's encounter with Dimorphos completely shattered our assumptions about what these space rocks are actually made of. When mission scientists dove deep into analyzing why the impact was so devastatingly effective, they discovered that Dimorphos wasn't the solid, monolithic boulder they had expected. It was what researchers now call a rubble pile, essentially a loose collection of rocks, dust, and debris, held together by nothing more than weak gravitational forces. This revelation explained everything about the spectacular 32-minute orbital change and why the debris plume was so massive. Think of it like the difference between hitting a concrete wall versus a pile of gravel. The energy transfer is completely different. When DART slammed into this cosmic rubble pile, it didn't just create a neat crater like punching solid rock. Instead, it excavated enormous amounts of material, launching chunks of Dimorphos into space and creating that dramatic comet-like tail that telescopes tracked for weeks. This discovery fundamentally changed how scientists classify near-Earth asteroids and assess potential planetary threats. The loose structure meant that kinetic impacts could be incredibly effective against similar rubble pile asteroids, potentially making planetary defense missions far more successful than anyone had dared hope. But it also raised new questions. How many potentially dangerous asteroids share this loose, fragmented structure? The answer could determine whether future deflection missions are routine procedures or complex engineering challenges requiring completely different approaches. Strategic implications. One successful space crash just upgraded humanity's survival odds by millions. The strategic implications of DART's overwhelming success rippled through every space agency and planetary defense program on Earth, fundamentally reshaping how we approach the cosmic threat of asteroid impacts. When the momentum enhancement discovery proved that deflecting dangerous asteroids could be 26 times easier than previously calculated, it wasn't just a scientific breakthrough. It was a species-level game-changer that moved us from theoretical planetary defense to proven, practical capability. Military strategists, space engineers, and government officials suddenly realized that protecting Earth from city-killer asteroids might not require the massive, expensive missions they had been planning for decades. The implications extend far beyond just building bigger rockets or spending more money. This discovery means that relatively small, affordable spacecraft could potentially redirect near-Earth objects that pose existential threats to human civilization. Space agencies worldwide began recalculating their planetary defense budgets, realizing they could potentially defend against multiple asteroid threats with the same resources previously allocated for single missions. The kinetic impactor technique went from experimental concept to proven technology overnight, giving humanity its first real planetary defense weapon that actually works better than designed. But perhaps most importantly, the success demonstrated that we don't need decades of warning to mount an effective defense. The momentum enhancement effect means faster, more responsive missions could potentially handle threats detected with shorter lead times, dramatically improving our cosmic security posture. Hera mission planning. The real investigation starts now. While DART proved that humanity can successfully punch asteroids off course, the European Space Agency wasn't about to let this cosmic crime scene go unexamined. Enter Hera mission planning, the detective work that will finally reveal exactly what happened when our spacecraft obliterated Dimorphos, and why the results were so spectacularly beyond expectations. Scheduled to launch in 2024, this follow-up mission will arrive at the Didymos system in 2026 to conduct the most detailed forensic analysis of an asteroid impact in human history. Think of Hera as the cosmic CSI team, arriving to photograph the crater, measure the debris, and piece together every detail of humanity's first successful planetary defense demonstration. But Hera isn't just satisfying scientific curiosity, it's gathering critical intelligence for future planetary defense missions. The spacecraft will precisely measure Dimorphos's mass, analyze the crater's dimensions, study the asteroid's internal structure, and determine exactly how much material was ejected during impact. This data is absolutely crucial because the next time we need to deflect an asteroid, it won't be a test. It could be the difference between civilization and catastrophe. Hera's findings will help scientists understand whether the momentum enhancement effect was a lucky accident or a predictable phenomenon that can be reliably reproduced. Armed with this knowledge, future deflection missions can be planned with surgical precision, ensuring that when humanity faces a real cosmic threat, we'll know exactly how hard to hit it. Planetary defense evolution. From asteroid hunters to cosmic guardians in just one successful crash. The planetary defense evolution triggered by DART's triumph represents the most significant shift in humanity's approach to cosmic threats since we first started tracking near-Earth objects. Before September 2022, planetary defense was largely theoretical. Scientists could model asteroid impacts, calculate trajectories, and propose deflection strategies. but nobody actually knew if any of it would work when push came to shove. Now, with real data proving that kinetic impactors are devastatingly effective, space agencies worldwide are completely rewriting their threat assessment protocols and emergency response procedures. The momentum enhancement factor isn't just being incorporated into computer models, it's fundamentally changing how we categorize asteroid risks and allocate planetary defense resources. This evolution goes beyond just updating equations and mission plans. Countries that never had serious planetary defense programs are suddenly investing in asteroid detection networks and deflection capabilities. The International Space Station partners are collaborating on advanced warning systems, while private companies are developing rapid response spacecraft that could be deployed within months rather than years. The success has also accelerated development of next-generation asteroid hunting telescopes and improved orbital prediction algorithms. Most importantly, the psychological shift is enormous. Humanity has moved from passive observers of cosmic threats to active defenders of our planet. We're no longer just hoping that dangerous asteroids will miss us, we now have proven technology to make sure they do. The age of planetary defense isn't coming someday. It arrived the moment Dimorphos got knocked sideways by human ingenuity. Mission success redefinition. Success isn't always about hitting your target, sometimes it's about completely redefining what success means. Mission success redefinition became the most unexpected outcome of the entire DART program, fundamentally changing how space agencies measure achievement in planetary defense missions. Before impact, NASA had already declared the mission a triumph simply for demonstrating that humans could accurately navigate a spacecraft across 370 million kilometers and hit a target the size of a football stadium. The primary objective was purely technological: prove the guidance systems work, test the kinetic impactor concept, and measure any detectable change in Dimorphos's orbit, no matter how small. Mission planners would have celebrated even a 10-second orbital shift as groundbreaking proof of concept. But the universe had other plans. When the 32-minute orbital period change was confirmed, it didn't just exceed expectations, it obliterated every benchmark scientists had established for what constituted mission success. This wasn't incremental progress, it was a quantum leap that forced mission planners to completely recalibrate their success metrics for future planetary defense operations. The 26-fold enhancement over predicted results meant that DART had essentially accomplished what multiple missions were designed to achieve. Space agencies worldwide began questioning whether their own success criteria were too conservative, whether they were underestimating human technological capabilities, and how to properly set goals for missions venturing into uncharted scientific territory. The redefinition cascaded through every future mission proposal, with engineers now expected to plan for spectacular success rather than modest achievement. Debris management and safety concerns. What happens when your successful space mission accidentally creates a cosmic mess? The debris management and safety concerns following DART's spectacular impact revealed that planetary defense isn't just about hitting asteroids, it's about dealing with the aftermath of turning space rocks into temporary comets. When Dimorphos got walloped on September 26, 2022, it didn't just change its orbit, it transformed into a debris-spewing machine that kept astronomers busy for months tracking every chunk of ejected material. Ground-based observatories worldwide suddenly found themselves monitoring a massive cloud of asteroid fragments spreading through space, creating an unprecedented challenge in space situational awareness and collision risk assessment. The spectacular debris plume that made DART so successful also raised serious questions about future deflection missions near critical space infrastructure. The ejected material created a comet-like tail visible through telescopes for weeks, with chunks of Dimorphos scattered across thousands of kilometers of space. Mission controllers had to carefully track this debris field to ensure it posed no threat to other spacecraft operating in the region, while also studying its behavior to improve debris modeling for future planetary defense operations. This unexpected consequence highlighted a crucial gap in mission planning. While everyone focused on successfully deflecting the asteroid, nobody had fully anticipated the complexity of managing the resulting space debris. The lesson was clear. Future deflection missions targeting asteroids closer to Earth or near valuable satellites will need sophisticated debris mitigation strategies to prevent turning one cosmic threat into dozens of smaller ones. Precision requirements for real threats. Practice makes perfect, but real asteroids don't give you second chances. The precision requirements for real threats expose the sobering reality behind DART's celebration-worthy success. While humanity proved we can deflect asteroids, the margin for error when facing actual Earth-threatening objects is absolutely zero. Unlike the controlled experiment with Dimorphos, where scientists had years to plan and could afford to overshoot their deflection goals, a genuine planetary defense scenario demands surgical precision that accounts for every variable imaginable. The momentum enhancement effect that made DART so spectacularly successful also introduced a new layer of complexity. Future deflection missions must accurately predict how much debris each target asteroid will eject, because the difference between nudging a space rock safely away and accidentally hurling it toward a populated area could determine the fate of millions. The challenge intensifies when considering that every potentially hazardous asteroid has unique characteristics that could dramatically affect deflection outcomes. Rubble pile asteroids like Dimorphos might respond completely differently than solid metallic objects, icy comets, or loosely bound dust clouds. Mission planners now face the daunting task of developing deflection strategies that work across this entire spectrum of cosmic threats, all while operating under the pressure that failure means catastrophic impact. The years of advance warning required for successful deflection means that asteroid detection networks must identify threats earlier and with greater accuracy than ever before. One miscalculation in trajectory, timing, or target composition could turn humanity's greatest technological achievement into its most devastating mistake. That's how NASA turned one perfectly executed space crash into humanity's greatest planetary defense breakthrough. The DART mission didn't just prove we can protect Earth from asteroid threats, it showed us we're way better at cosmic billiards than anyone dared hope. But this is just the beginning of our journey into the incredible world of space exploration and planetary defense. If you love discovering how we literally punched an asteroid off course, smash that subscribe button and hit the bell icon so you never miss the latest mind-blowing space facts. Drop a comment below. What space mission do you want Space Facts to cover next? The universe is full of incredible stories, and we're just getting started. Imagine discovering a cosmic time capsule from the ancient galaxy, older than our entire solar system. On July 1, 2025, astronomers spotted something extraordinary racing through space at an incredible 137,000 miles per hour. This wasn't just any ordinary visitor, it was 3I Atlas, the third confirmed interstellar object ever detected, carrying secrets from a part of the galaxy we've never seen before. Discovery of 3I Atlas. What if I told you that finding an interstellar visitor requires watching the entire sky every single night? That's exactly what happened when the Atlas Survey Telescope in Rio Hurtado, Chile, made astronomical history. On July 1, 2025, this powerful sky scanner detected a faint moving object with the temporary designation A11PL3Z. Initially appearing as just a magnitude 18 point of light, the object was traveling through the border regions of constellations Serpens Cauda and Sagittarius. What made astronomers immediately suspicious was its peculiar motion, moving far too fast for any ordinary solar system object. The discovery observations were quickly submitted to the International Astronomical Union's Minor Planet Center, but follow-up observations from both professional and amateur astronomers around the world revealed something extraordinary. This wasn't bound by our sun's gravity at all. Within hours of the initial detection, telescopes across multiple continents were tracking this mysterious visitor, confirming that humanity had discovered another piece of the cosmic puzzle from beyond our solar neighborhood. The object's unusual path through space immediately suggested it originated from outside our solar system, making it only the third confirmed interstellar visitor in human history. Atlas Survey System. Ever wondered how we can monitor threats from space across the entire globe? The Asteroid Terrestrial Impact Last Alert System represents one of humanity's most ambitious skywatching projects. This network consists of 4 50-centimeter telescopes strategically positioned around the world in locations including Hawaii, Chile, and South Africa. Each telescope boasts an impressive 7.4-degree field of view, about 15 times the diameter of the full moon, allowing them to scan vast areas of sky in single exposures. The system operates with military precision. Each telescope surveys 1/4 of the observable sky 4 times per night at approximately 15-minute intervals. With 110 megapixel CCD cameras, these robotic sentinels can detect objects as faint as magnitude 19, while automatically tracking moving objects across multiple observations. The Chilean facility that discovered 3I Atlas represents the cutting edge of this technology, capable of processing thousands of astronomical images nightly, while automatically flagging potential threats or unusual visitors. This automated detection system has revolutionized our ability to spot cosmic wanderers before they disappear back into the darkness of interstellar space. The network's sophisticated algorithms can distinguish between asteroids, comets, and potentially dangerous objects within minutes of detection, providing crucial early warning capabilities for planetary defense. Object classification and naming. Have you ever witnessed the moment when a mysterious space object transforms from unknown to historically significant? The journey from A11PL3Z to 3I Atlas tells a fascinating story of modern astronomical detective work. Initially, when the object was first spotted on July 1, 2025, it received the temporary designation A11PL3Z, following standard protocols for newly discovered moving objects. Within just 24 hours, observations on July 2, 2025 by multiple observatories including the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something crucial: a faint coma and 3 arcsecond tail. This discovery immediately elevated the object's status from potential asteroid to confirmed comet, fundamentally changing how scientists would study and classify it. The Minor Planet Center then bestowed upon it the prestigious designation 3Y Atlas, where 3I signifies it as the third confirmed interstellar object ever discovered by humanity. Simultaneously, it received the official cometary designation C/2025N1 according to international naming conventions. By the time this announcement was made, astronomers had already collected 122 observations from 31 different observatories worldwide, demonstrating the unprecedented global coordination required to track these elusive cosmic visitors. The rapid classification process highlighted how modern astronomy has evolved to quickly identify and study these rare interstellar objects before they vanish forever. Orbital characteristics. So what does it actually take for an object to completely escape the gravitational grip of our solar system forever? Well, 3I/Atlas possesses orbital characteristics that are honestly nothing short of extraordinary, placing it among the most extreme objects ever studied. Racing through space with a hyperbolic excess velocity of 58 kilometers per second relative to the Sun, this interstellar visitor moves significantly faster than both previous interstellar objects, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory follows an extremely hyperbolic orbit, with an orbital eccentricity of 6.141, which is the highest ever recorded for any confirmed interstellar object in human history. This extreme eccentricity makes the comet's path appear almost perfectly straight rather than curved, at least when you look at it from our solar system. 3I/Atlas will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units, so that's roughly 203 million kilometers away. Thankfully, Earth remains completely safe during this encounter, as the comet will never approach closer than 1.8 AU to our planet. After its solar encounter, this ancient visitor will continue its relentless journey back into the vast emptiness of interstellar space, carrying with it the gravitational signature of its dramatic passage through our solar system for, well, billions of years to come. Physical properties. So, how do you measure something that's surrounded by a cloud of gas and dust, millions of kilometers away, out there in the depths of space? Determining 3I/Atlas's physical characteristics actually presents some pretty unique challenges, mostly due to its active cometary nature, and all the interference from its surrounding coma. Early estimates suggest the nucleus diameter ranges somewhere between 0.8 to 11 kilometers, though astronomers tend to favor the lower end of this range based on brightness measurements and activity levels. The Gran Telescopio Canarias made a crucial breakthrough between July 2nd and 5th, 2025, determining that the nucleus rotates with a period of 16.79 hours, The brightness variations are only 0.2 magnitudes, which actually suggests a relatively round shape. Color observations using the Palomar 200-inch telescope on July 3, 2025, revealed some fascinating details about its surface composition: a GR color index of 0.43 magnitudes, RI of 0.16 magnitudes, and a spectral slope of about 1.3% per 100 nanometers. The comet's absolute magnitude measures approximately 12, which corresponds to a nuclear radius of roughly 10 kilometers, assuming typical asteroid-like albedo values. These measurements, though, become increasingly difficult as the comet develops a more extensive coma, making it really challenging to distinguish the solid nucleus from all the surrounding ejected material that creates that classic fuzzy appearance. Advanced imaging techniques and computer modeling are being used to separate the nucleus signal from the contaminating coma light. Comet activity features. So what makes 3I/Atlas behave more like 2I/Borisov than the mysterious and inactive 1I/Oumuamua? Unlike the first interstellar visitor, which showed no cometary features whatsoever during its passage, 3I/Atlas actually displays clear signs of vigorous activity even while it's 4.5 astronomical units from the Sun. Much farther out than most solar system comets start showing activity. The comet exhibits a distinct fuzzy appearance in telescope images, which indicates a well-developed coma, a cloud of gas and icy dust particles ejected from the nucleus surface as solar radiation heats up volatile materials. Spectroscopic observations by Gemini South and the NASA Infrared Telescope Facility on July 5 and 14, 2025, confirmed that the coma contains water ice and silicate grains with radii of about 10 micrometers. The dust cross-section within 10,000 kilometers of the comet measures 230 square kilometers, assuming an albedo of 0.10. As solar heating intensifies the sublimation process during its approach, micrometer to millimeter scale particles are ejected at speeds ranging from 0.01 to 1 meter per second, resulting in a dust mass loss rate of 0.1 to 1.0 kilograms per second. This activity level suggests the presence of highly volatile ices that have remained frozen for billions of years, potentially preserving ancient chemical signatures from its original star system. Amateur contributions. So, how did citizen scientists around the world help unlock the secrets of this remarkable interstellar visitor? Well, the discovery and characterization of 3I/Atlas marked a historic milestone for amateur astronomy communities worldwide. It really shows how modern technology has, democratized space exploration in ways we couldn't have imagined a few decades ago. Let me tell you about Vamshi Kesareddy, a dedicated citizen astronomer. On July 4, 2025, he achieved something pretty remarkable by successfully capturing 3I/Atlas using a unistellar telescope and measuring its brightness at 17.8 magnitude. This observation potentially represents the faintest object ever detected by the unistellar network, which just goes to show the incredible capabilities of modern citizen science equipment and automated imaging systems. And there's more. Amateur astronomer Sam Dean made some crucial contributions too, by meticulously identifying additional Atlas prediscovery observations from June 5 to the 25th, 2025. This extended the observational arc and really improved the orbital calculations. Meanwhile, the Las Cumbres Observatory Network, using 0.36-meter telescopes at Haleakala and the 2.0-meter Falks Telescope North, provided essential photometric data. They showed light curve variations of less than 0.2 magnitudes over a 29-hour time span. All these amateur contributions proved absolutely invaluable, as 3I/Atlas traveled through star-crowded fields near the galactic center. In fact, professional surveys might have missed it entirely, because the dense stellar background creates confusion in automated detection systems. So it's clear that the passion and dedication of citizen scientists are, honestly, making a real difference in our understanding of the cosmos. Surface composition. So, what can the colors and reflected light from 3I/Atlas actually tell us about its ancient origins in a distant star system? Spectroscopic analysis, reveals some fascinating details about this interstellar wanderer's composition and the environment where it formed billions of years ago. Observations using the Very Large Telescope on July 4 and 5, 2025, didn't detect clear signs of hydroxides and cyanides gases in the coma, placing upper limits on outgassing rates of about 8.2 times 10 to the 26th molecules per second, and 5.6 times 10 to the 23rd molecules per second, respectively. However, the comet's red spectral characteristics did show up in multiple independent observations, with a spectral slope measuring 18 plus or minus 4% per 1,000 angstroms, making it significantly redder than most solar system comets we've studied. The water ice and silicate mineral composition, detected through infrared spectroscopy, suggests a pretty typical cometary makeup, but the comet's distance from the sun during those early observations meant that many volatile compounds stayed frozen solid. Scientists predict that carbon dioxide and carbon monoxide ices are likely present within 3 I/Atlas, though these substances haven't yet been detected as gas emissions. Future observations by the James Webb Space Telescope will provide more detailed compositional analysis as the comet gets closer to the sun and becomes more active, potentially revealing the pristine chemistry preserved from its formation environment. Interstellar object density. So just how common are these cosmic visitors from beyond our solar system wandering through the galaxy? The discovery of 3 I/Atlas actually provides crucial insights into the population density of interstellar objects that have been ejected from their parent star systems and now drift through the vast spaces between stars. Based on 3 I/Atlas's characteristics and the circumstances of its detection, astronomers calculate a spatial number density of approximately 1 in 1,000 objects per cubic astronomical unit for objects with radii greater than or equal to that of 3 I/Atlas. This means that within a cube of space measuring 1 astronomical unit on each side, we might expect to find about 1 object of 3 I/Atlas's size or larger every 1,000 such volumes throughout local interstellar space. The rapid succession of interstellar discoveries, first 1 I/Oumuamua in October 2017, then 2 I/Borisov in August 2019, and now 3 I/Atlas in July 2025, suggests these objects may be far more common than previously thought by theoretical models. Statistical models now indicate that millions of such objects likely pass through the outer solar system undetected each year, basically invisible to our current detection capabilities. The Atlas network's improved sensitivity and comprehensive sky coverage now mean we're finally reaching the detection threshold necessary to regularly spot these ancient wanderers from distant stellar neighborhoods. Origins and age speculation. Could 3 I/Atlas actually be older than our entire solar system, carrying materials from the early galaxy? The comet's extreme velocity and unusual trajectory provide some tantalizing clues about its ancient origins in a very different cosmic environment. Moving at 58 kilometers per second relative to the Sun, 3 I/Atlas likely originated from the Milky Way's thick disk, which is a region populated by older stellar populations that formed when the galaxy was younger and chemically different. This suggests the comet could be at least 7 billion years old, which is significantly older than our 4.6 billion-year-old solar system, and potentially containing pristine materials from the early galaxy. The thick disk connection indicates 3 I/Atlas formed around low metallicity stars that existed when heavy elements were much rarer throughout the cosmos. Its high velocity suggests it was violently ejected from its parent system through dramatic gravitational interactions, possibly involving massive planetary bodies or close stellar encounters that flung it into interstellar space. The comet's water-rich composition and early activity patterns support theories that it formed in the outer regions of an ancient planetary system, where volatile ices could condense and survive for billions of years in the cold depths of space. This cosmic time capsule really offers an unprecedented opportunity to study materials that predate our solar system's formation. As 3 I/Atlas continues its epic journey toward the Sun, reaching closest approach on October 29, 2025, it carries with it secrets from the ancient galaxy that we're only beginning to unlock. This remarkable visitor reminds us that space is filled with wandering worlds, each telling a unique story of cosmic evolution. For more mind-blowing space discoveries that challenge everything we thought we knew about our universe, make sure to like, share, and subscribe to Space Facts, where the cosmos reveals its greatest mysteries. Right now, as you're watching this video, there are mysterious worlds spinning in the darkness beyond Pluto that NASA has been quietly discovering. Worlds so bizarre they're rewriting everything we thought we knew about our solar system. These aren't just random chunks of ice floating in space. These are full-blown alien worlds with their own moons, ring systems, and physics-defying properties that would make science fiction writers jealous. But here's the kicker. Some of these discoveries are so recent that most people have never even heard their names. Did you know there's a world out there that spins so fast it literally stretched itself into the shape of a football? The dwarf planet that dethroned Pluto. Did you know there's a world out there so massive it literally kicked Pluto out of the Planet Club? Meet Eris, the cosmic troublemaker that changed everything we thought we knew about our solar system. This icy giant sits way beyond Pluto's orbit, roughly 68 times farther from the Sun than Earth, making it one of the most distant objects we've ever discovered in our neighborhood. What makes Eris absolutely mind-blowing is that it's actually 27% more massive than Pluto, despite being slightly smaller in size. Think of it as the dense, muscular cousin that nobody talks about at family gatherings. When astronomers first spotted this beast in 2005, it sparked the Great Planetary Identity Crisis that ultimately led to Pluto's demotion to dwarf planet status. But here's where it gets really wild. Eris is so far out there that it takes 557 Earth years just to complete one single orbit around our Sun. The surface temperature, a bone-chilling -400 degrees Fahrenheit, cold enough to freeze nitrogen solid. Named after the Greek goddess of chaos and discord, Eris lives up to its reputation by having an orbit so elliptical and tilted that it literally dances to its own cosmic rhythm. This frozen world even has its own moon called Dysnomia, named after Eris's daughter who was the goddess of lawlessness. Together, they're like the ultimate rebel duo of our solar system, proving that the most interesting characters always hang out in the shadows. The Easter Island of space. What if I told you there's a world out there named after an Easter Island creation god that's hiding secrets NASA never expected? Welcome to Makemake, the reddish dwarf planet that's rewriting the rules of what we thought possible in the outer solar system. This bizarre world sits about 45 times farther from the Sun than Earth, cruising through the Kuiper Belt like a cosmic ghost wrapped in mystery. Here's what makes Makemake absolutely fascinating. Its surface is covered in frozen methane and nitrogen, giving it this eerie reddish-brown color that makes it look like a giant rusty marble floating in space. But the real shocker came when scientists discovered that this supposedly lonely world actually has a tiny dark moon they nicknamed MK2. This little companion is so dark it absorbs almost all light that hits it, making it nearly invisible and explaining why it took astronomers over a decade to spot it after finding Makemake itself. The temperature on this frozen wasteland? A brutal -406 degrees Fahrenheit, so cold that even the atmosphere would freeze solid if it had one. What's really mind-bending is that Makemake completes one orbit around our Sun every 310 Earth years, meaning since its discovery in 2005, it's barely moved from where we first spotted it. Named after the Polynesian creator deity from Easter Island, this world represents one of the most significant discoveries in our solar system's outer reaches, proving that even in the darkest, coldest corners of space, there are still incredible surprises waiting to be uncovered. The spinning football planet. There's a world spinning so fast in our solar system that it literally stretched itself into the shape of a football, and it comes with its own ring system that shouldn't even exist. Say hello to Oumuamua, the cosmic speed demon that's breaking every rule we thought we knew about how planets behave. This elongated freak of nature rotates once every 4 hours, making it one of the fastest spinning objects in our entire solar system. So fast that centrifugal force has warped it into an egg-like shape that's twice as long as it is wide. Located about 43 times farther from the Sun than Earth, Oumuamua is essentially a giant spinning ice ball made mostly of crystalline water ice, reflecting sunlight so brilliantly that it practically glows in the darkness of space. But here's where things get absolutely insane. This spinning football has 2 moons, Hi'iaka and Namaka, named after Hawaiian goddesses, and they're likely chunks that got flung off during some catastrophic collision billions of years ago. The real kicker? In 2017, scientists discovered that Oumuamua has its own ring system, making it the first known ringed object beyond Neptune. These rings are incredibly thin and dark, orbiting around Oumuamua's equator like a cosmic hula hoop. What makes this discovery so shocking is that according to everything we know about physics, rings shouldn't be stable around such a rapidly rotating, oddly shaped object. Yet, there they are, defying our understanding and proving that the outer solar system is full of impossible worlds doing impossible things. The Lonely Wanderer. Ever wonder what happens when a world gets so lonely that it takes 11,400 years just to say hello to the sun once? Meet Sedna, the cosmic hermit that's rewriting everything we thought we knew about the edge of our solar system. This blood-red dwarf planet is currently sitting about 84 times farther from the sun than Earth. But here's the kicker. Yeah, that's actually its close approach. When Sedna reaches its farthest point in its orbit, it ventures out to a mind-boggling 937 astronomical units away, making it so distant that the sun would look like just another bright star in the sky. What makes this world absolutely fascinating is its deep crimson color, caused by organic compounds called tholins that have been baked by cosmic radiation for billions of years. The surface is a frozen wasteland of water ice, methane, and carbon dioxide, with temperatures that never rise above -400 degrees Fahrenheit. But here's where Sedna gets really mysterious. Its orbit is so extreme and elongated that something massive must have gravitationally yanked it into this bizarre path billions of years ago. Scientists think it could have been a rogue star that passed through our solar system when the sun was young, or maybe even evidence of the legendary Planet 9 lurking in the outer darkness. Sedna rotates incredibly slowly, taking about 10 hours to complete one spin, and it's completely alone out there with no known moons. This lonely wanderer represents our first glimpse into the inner Oort cloud, that mysterious region where comets are born. The Ancient Surprise. There's a world out there that's completely shattering our understanding of physics by sporting rings that absolutely should not exist. Meet Quaoar, the rebel dwarf planet that's making scientists question everything they thought they knew about how ring systems work. This icy troublemaker sits about 43 times farther from the sun than Earth, cruising through the Kuiper Belt with a secret that wasn't discovered until 2022. Named after the creation deity of the Tongva people of Southern California, Quaoar is roughly half the size of Pluto, but packs enough surprises to keep astronomers scratching their heads for years. Here's what makes this world absolutely mind-blowing. It has a ring system that orbits at a distance where rings simply cannot exist according to our current understanding of celestial mechanics. These rings sit way beyond what's called the Roche limit, the theoretical boundary where a planet's gravity should tear apart any orbiting material and turn it into moons instead. Yet Quaoar's rings are just hanging out there, perfectly stable, basically giving physics the middle finger. The rings themselves are incredibly faint and narrow, made up of tiny particles that somehow resist clumping together into larger objects. What's even more bizarre is that Quaoar has a small moon called Weiwat, named after Quaoar's son in Tongva mythology, which orbits much farther out than the rings. This setup defies everything we know about how ring systems should behave, suggesting there are fundamental forces at work in our solar system that we're only just beginning to understand. Pluto's anti-twin. What if there's a world out there that's locked in a cosmic dance with Pluto, orbiting in perfect harmony but always staying on the exact opposite side of the solar system? Welcome to Orcus, the anti-Pluto that's proving the universe has a twisted sense of symmetry. This dark, mysterious dwarf planet sits roughly the same distance from the sun as Pluto, about 39 times farther than Earth, but here's where things get absolutely wild. It's trapped in what scientists call a 1-to-2 orbital resonance with Pluto, meaning for every 2 orbits Pluto makes, Orcus completes exactly 1. But the real kicker is that they're positioned like cosmic opposites, always maintaining maximum separation as they waltz through space together. Named after the Roman god of the underworld and punisher of broken oaths, Orcus is significantly smaller than Pluto but shares some eerily similar characteristics. Its surface is covered in water ice mixed with organic compounds, giving it a grayish appearance that makes it look like Pluto's shadow twin. The most fascinating part? Orcus has its own moon called Vanth, named after an Etruscan demon, and this moon is unusually large compared to its parent, almost like a mini version of the Pluto-Charon system. What makes this relationship so bizarre is that despite being gravitationally linked in this eternal dance, Orcus and Pluto will never get closer than about 18 astronomical units apart. They're like cosmic dance partners who are forever destined to mirror each other's movements while never actually meeting, creating one of the most elegant and mysterious orbital relationships in our entire solar system. The Chaos Bringer. There's a world tumbling through space so chaotically that scientists can't even figure out which way is up, and it's named after a Chinese water god known for causing floods and chaos. Meet Gong Gong, the cosmic troublemaker that's spinning in such a bizarre way, it's making astronomers question everything they know about planetary rotation. This dark reddish dwarf planet lurks about 67 times farther from the Sun than Earth, taking a whopping 554 years to complete just one orbit around our star. What makes Gong Gong absolutely mind-bending is its rotation. Instead of spinning like a normal planet with a stable axis, it tumbles end over end in a completely unpredictable pattern that changes constantly. Scientists think this chaotic tumbling was caused by a massive collision sometime in its past, possibly the same impact that created its small moon, Xiangliu, named after Gong Gong's nine-headed serpent companion in Chinese mythology. The surface of this world is covered in dark, methane-rich materials that absorb most of the sunlight hitting it, making it one of the reddest objects in the outer solar system. Here's what's really wild. Gong Gong is so massive that it's right on the borderline of being large enough to pull itself into a round shape, but its chaotic rotation and composition keep it slightly elongated. The temperatures on this frozen wasteland never rise above -400 degrees Fahrenheit, cold enough to freeze nitrogen solid. This tumbling giant represents one of the most dynamically unstable objects we've discovered in our solar system, proving that even billions of years after formation, some worlds are still dealing with ancient cosmic trauma. The Slow Giant. There's a cosmic giant lurking so far out in space that it takes over 1,100 years just to say hello to the sun once. And, scientists almost missed it completely while hunting for dark energy. Meet 2014 UZ-224, nicknamed DD for Distant Dwarf, the slow-motion behemoth that's redefining what we know about the edge of our solar system. This mysterious world sits approximately 8.5 billion miles away from the Sun right now, making it nearly 3 times farther out than Pluto, and ranking it as the third most distant known object in the Kuiper Belt. What makes this discovery absolutely incredible is that it was found completely by accident. Astronomers were using the dark energy camera to map distant galaxies when undergraduate students spotted this single moving dot creeping across the cosmic background. The sheer size of this world is mind-blowing, measuring roughly 395 miles across, which makes it about 2/3 the diameter of the dwarf planet Ceres, and roughly half the size of Pluto. Here's where things get really wild. 2014 UZ-224 has one of the most extreme orbits ever discovered, swinging as close as 38 astronomical units from the Sun and reaching as far out as 180 astronomical units, creating an incredibly elongated path that takes 1,147 years to complete. The surface of this distant world is incredibly dark, reflecting only 13% of the sunlight that hits it, making it one of the darkest objects in our solar system. What's fascinating is that this world is currently headed inward toward the Sun and won't reach its closest approach until the year 2142. The Snowman of Space. What if I told you there's a cosmic snowman floating 4 billion miles away that's revealing the deepest secrets of how our entire solar system was born? Meet Arrokoth, the most distant object ever visited by a spacecraft, and the ultimate time capsule that's rewriting everything we thought we knew about planetary formation. This bizarre double-lobed world looks exactly like a flattened snowman, with 2 rounded sections gently touching each other in what scientists describe as the most gentle cosmic kiss ever recorded. Here's what makes this discovery absolutely mind-blowing. When NASA's New Horizons spacecraft flew by Arrokoth on New Year's Day 2019, it revealed that this ancient relic formed through a process so delicate that its 2 halves came together at just 7 miles per hour, essentially docking like spacecraft rather than smashing together violently. The surface of this primordial world is incredibly red, even redder than Pluto, and recent analysis has revealed something that could change our understanding of life's origins. It contains sugars like ribose and glucose, the fundamental building blocks of life itself. What's truly fascinating is that Arrokoth has remained virtually unchanged for 4.5 billion years, preserved in the deep freeze of the Kuiper Belt like a cosmic fossil. Scientists believe this snowman-shaped world formed when a localized cloud of primordial material gently collapsed and fused together, proving that planet formation can happen through surprisingly gentle processes rather than violent collisions. This discovery is revolutionizing our understanding of how planets form and suggesting that the building blocks of life might be far more common in the universe than we ever imagined. The Phantom World. What if there's an invisible giant lurking in the darkest corners of our solar system? A phantom world so massive it's secretly controlling the orbits of distant objects like a cosmic puppet master. Meet Planet 9, the theoretical super-Earth that could be the most significant discovery in astronomy since Neptune was found over 150 years ago. This mysterious world is believed to be roughly 10 times more massive than Earth, and orbits somewhere between 400 to 800 times farther from the Sun than our planet, making it so distant that it would take between 10,000 to 20,000 years just to complete one orbit around our star. Here's what makes this discovery absolutely mind-blowing. Scientists haven't actually seen Planet 9 yet, but they know it's there because of the gravitational fingerprints it's leaving behind. 6 distant objects in the Kuiper Belt all have their orbits mysteriously aligned in the same direction and tilted at the same 30-degree angle, something that would be virtually impossible without a massive planet shepherding them from the shadows. Computer simulations show that Planet 9's gravity is so powerful it could have tilted our entire solar system by 6 degrees over the past 4.5 billion years, finally solving a mystery that has puzzled astronomers for decades. Recent studies suggest there's at least a 40% chance this phantom planet actually exists, and it might be the core of a giant planet that was violently ejected by Jupiter during the chaotic early days of our solar system. With surface temperatures around minus 375 degrees Fahrenheit and a diameter 7.5 times larger than Earth, Planet 9 represents the ultimate cosmic hide-and-seek champion. So there you have it. 10 absolutely mind-blowing worlds that prove our solar system is way stranger than we ever imagined. From spinning footballs to phantom planets, these discoveries are just the beginning of what's waiting out there in the cosmic darkness. If these bizarre worlds blew your mind as much as they did mine, make sure you hit that subscribe button and ring the bell icon so you never miss our latest space discoveries. Drop a comment below and tell me which of these worlds surprised you the most. Was it the tumbling chaos of Gong Gong or the invisible giant Planet 9? Thanks for joining me on this cosmic journey, and I'll see you in the next Space Facts adventure.